Assalamualaikum and welcome to Cambridge Chemistry with sarwatahmed. Uh, Today I will solve, in this video I will solve October-November 2023 variant 4-2 paper 5070. This is paper 4 and paper 4 alternative to practical. You must answer on the question paper. No additional materials are required. Answer all questions. So use a black or dark blue pen. You may use an HB pencil for any diagram or graphs. This is very important to note down. Write your name, center number and candidate's number in the boxes at the top of the page. Write your answers to each question in the space provided. Do not use an erasable pen or correction wheel. Do not write on any barcodes. You may use a calculator. You should know all your working and use appropriate unit. Let's start. Question number 1. A student investigates the electrolysis of concentrated aqueous sodium chloride. You know, in concentrated aqueous sodium chloride, you should know the ions present in this solution. We have 4 types of ions: sodium chloride, H positive and OH ion. These 2 ions are present in this solution. Figure 1.1 shows the apparatus the student uses. So he mentioned that concentrated aqueous solution sodium chloride, this is graphite electrodes, this is cathode and this is anode. At anode, chlorine gas is collected and name the apparatus X. X is the test tube. Give a reason why iron electrodes are not used during this lecture. Iron is not inert, graphite is inert, so that's why graphite electrodes are used. Iron is not inert because iron can react with chlorine gas producing at the cathode. Chlorine gas is produced at the anode during this electrolysis. Describe and explain one safety precaution of the student takes during this electrolysis. You know, the chlorine is poisonous and toxic gas, so the experiment involving such gases is carried out in fume cupboard. So use fume cupboard. Explanation: chlorine gas is toxic or anyone can inhale this gas in the lab. A different gas is produced at the cathode during this electrolysis. Name the gas. Describe a test for this gas. The name of the gas is different gas if we use dilute sodium chloride, and after this experiment, you know that the solution become dilute. So hydrogen gas is collected at the cathode. So in this case, hydrogen gas is at chlorine gas is at anode because this is concentrated aqueous sodium chloride, and at cathode hydrogen gas is collected like 2H positive. This is reaction at cathode plus 2 electron form H2 gas, and this is reaction at anode. Cl2 plus 2 electron. So name of the gas is hydrogen. Description of the test and result: bring the lighted supplant. Gas produced pops in flame with lighted supplant. Sulfuric acid. Question number 2. Sulfuric acid is neutralized when it is added to aqueous sodium hydroxide. So this is the reaction. The reaction is exothermic. I have earlier discussed in the previous video that the neutralization reaction is exothermic. So this is neutralization reaction because acid neutralizes alkali and alkali neutralizes acid to form salt and water. P is 1.25 mole per dm cube aqueous sodium hydroxide. Q is dilute sulfuric acid. A student determine the concentration of sulfuric acid in Q. The student does 6 experiments. Student step 1 uses volumetric pipette to add. This is the volumetric pipette. And it is used to measure fixed volume of liquid. This is 25 centimeter cube pipette. up till if we when you fill the liquid up till this, so it is 25 centimeter cube volume. To a plastic cup, place plastic cup with thermometer. This is thermometer. Plastic cup uses a measuring cylinder to add 20 centimeter cube distilled water to the plastic cup. So add 20 centimeter cube, first 25 centimeter cube of P, which is P is sodium hydroxide, and then 20 centimeter cube distilled water, and stir the mixture in the cup with a thermometer and record its temperature to the nearest 0.5 degrees centigrade. Step 4 uses a burette to add 5 centimeter cube of Q to the plastic cup and stirs. Records the highest temperature reached. Step 6 empties the plastic cup and rinses it with water. Step 7 repeats step 1 to 6 using 5 different volumes of distilled water and Q, so that the total volume in the cup is always 50 centimeters. This is very important point. Total volume should be 50 centimeter cube in this and 50 centimeter cube the distilled water, and volume of Q and volume of P, the total should be 50 centimeter cube. Experiment number 125 centimeter cube volume of P, 20 is this, and this is equal to 50 centimeter cube. This is also equal to 50 centimeter. So this is the blank you have to fill by keeping all this volume is equal to 50 centimeter cube. This is 25, this is 10 centimeter cube, and total is 35 and 15. So you write down 15 over here, and 25, 7 and 18. This is equal to also 50. This is also equal to 50. This is also equal to 50, and this is also equal to 50. 23. This is the initial temperature for experiment 1, and all these readings are table is filled, and this is blank, going to blank. Please keep it in mind, temperature rise is always highest temperature minus initial temperature, highest minus initial. Okay, so 25.5 minus 23 is equal to 2.5, and 29.5 minus 24.5 is equal to 5, and in this way you can fill the table. Complete table 2.1 by filling in the 3 missing values. Parts of the thermometer used in experiment 3 are shown in figure 2.1. The liquid levels inside the thermometer are missing. Complete figure 2.1 by drawing in the liquid level to show the initial temperature in experiment 3, the highest temperature reached in experiment 3. So this is 25 centimeter cube is the initial, and highest is the 32.5. Draw a graph of the temperature rise against volume of Q. This is volume of Q on the grid in figure 2.2. You should plot the point 0 to 0 as there is no temperature rise when no Q is added. Plot the temperature rise and volume of Q from the table 2.1. Draw a straight line of the best fit for first 4 points. So you should follow all these instructions while drawing the graph, and draw a straight line best fit for 3 points. These are the draw 1, 2, 3. This is a straight line, this is a straight line, and these are the 4 points which you draw upward. So this is the intersect. So extend the lines. So this is extension of line like this, and this is extension of second line, and this is the intersect point, and over here the volume is 16, 15, nearly 16 centimeter cube. Okay, the point where the two lines intersect indicates the volume of Q that exactly neutralizes 25 centimeter cube of P. Determine the volume of Q where the two lines on the graph is intersect. So the This volume is 16 centimeter cube. P is 1.25 mole per dm cube aqueous sodium hydroxide. Use your answer to D to calculate the concentration of sulfuric acid in cube. So first calculate the moles of sodium hydroxide. This is the concentration of sodium hydroxide, and volume is given over here, that is 25. So 25 concentration into volume, or volume over 1000 into concentration. So this is the moles of sodium hydroxide, and now taking mole ratio to get moles of sulfuric acid. 2 moles of sodium hydroxide ratios 1 mole of sulfuric acid. We have moles of sodium hydroxide 0.03125, and mole of sulfuric acid is X. So the mole of sulfuric acid is now 0.015625. So concentration is equal to mole over volume into 1000. So this is the mole, 0.015625 divided by 16 is the volume of Q into 1000. So that is the concentration of Q, 0.9765 mole per dm cube. Describe and explain what happens to the gradient of the straight line for the first 4 points on the graph if a metal cup is used instead of a plastic cup. The graph will be less steeper as less loss of heat to the surrounding from metal cup. A burette may be used instead of measuring cylinder to measure the volume of water in these experiments. Suggest how this improves the experiment. Burette is more accurate than measuring cylinder, so more accurate result is obtained. Now state the dependent variable in this temperature. So temperature rise is the dependent variable because it is on y-axis, and on y-axis always dependent variable is there. On y-axis dependent, and on x-axis is independent variable. Please keep it in mind that on x-axis variable is independent, and on y-axis this is dependent variable always. So that's why I state the dependent variable in this set of experiment, that is temperature rise. This is qualitative analysis question. Question number 3. A student investigates solid Y, and this is solid Y and solution Z. Solid Y is white and contains carbonate ions. The test of student does on Y are shown in the table 3.1. First test of on solid Y. Add excess dilute sulfuric acid to Y in a boiling tube. Effervescence solid disappear. It means if carbonate ions are present in Y solid, so effervescence of carbon dioxide gas, which turns lime water milky. So add aqueous sodium hydroxide to the solution from test 1 until a change is seen. White precipitate. Add more aqueous sodium hydroxide to the mixture from the test tube until a further change is seen. White precipitate dissolves might be zinc ions or aluminium ion or lead ions are present, because these 3 cations dissolve in excess of sodium hydroxide. Predict the identity of the gas produced in test 1. Describe how the student tests the gas to confirm its identity. The gas is carbon dioxide because carbonate ions are present, he mentioned here. So that's why if carbonate ions are there, definitely will be carbon dioxide, but with addition of dilute sulfuric acid. Okay, the gas will turn lime water milky. Gas pass through lime water, and gas will turn lime water milky. The solution produced in test 1 contains an anion. Name the reagent that reacts with this anion to form a white precipitate when added to the solution produced in test 1 after the addition of dilute nitric acid. Barium nitrate is added, which gives white precipitate of sulfate and barium sulfate. The observations for test 3 are incomplete. State one other. When precipitate dissolves, so always write should be written over here that it dissolves to form colorless solution. So colorless solution is missing. Solid white contain only one cation. The student cannot identify the cation from the observation in table 1. Use table 3.1 to name the two cations. So zinc and ammonia, I have earlier discussed that if cations dissolves in excess of sodium hydroxide, zinc or aluminum or lead may be present. So zinc and aluminum are there. Describe an additional test the student does on the solution produced in test 1 to identify the cation and why. Add few drops of ammonia until change is seen, then excess. So if zinc is present, white precipitate dissolve. If zinc is present, white precipitate dissolves in excess. And for aluminum, white precipitates remain insoluble. Insoluble in excess. Solution B contains one cation and one anion. The cation contains two nonmetals. The student adds aqueous sodium hydroxide to G in a boiling fluid. Describe how the student completes this test to identify the cations in G. Warm the mixture, gas is evolved, which turns damp red litmus paper blue. The student adds dilute nitric acid and then aqueous silver nitrate to G. A precipitate is formed. It is difficult to tell the precipitate is white or green in color. Describe how the student uses separate aqueous solution of chloride and bromide to decide the color of the precipitate. Solution B is divided into the two portions and then add in both test tubes dilute nitric acid plus silver nitrate and compare the color. If white precipitate, then chloride ions are present. If green precipitate, then bromide ions are present. The student adds dilute nitric acid and then aqueous barium nitrate to Z. Predict the expected observation. No change as chloride ions are already present because over here white precipitates are formed. So barium nitrate, no change. So that's why chloride ions are present. A white precipitate green is the bromide. So that's why there is no change with addition of barium nitrate to Z. Copper 2 sulfate is a salt used to kill pests on plant leaves. Copper 2 sulfate is prepared by neutralizing dilute sulfuric acid with copper 2 oxide plan. An experiment to prepare pure dry crystals of copper 2 sulfate. So this is how this filtration and crystallization is used. Your plan should include the use of common laboratory apparatus. Same titration apparatus are required. Titration apparatus: pipette, burette, and conical flask. Sorry, not titration. So this is not titration. This is filtration and crystallization. So this apparatus is not required. Sorry. Apparatus is beaker, tripod stand, evaporating dish, filter paper, filter funnel, filter paper, filter funnel, and beaker. Your plan should include the apparatus needed, the method to use. So filtration and crystallization is used for preparing copper 2 sulfate. You may draw a diagram to help answer the question. We excess mass of copper 2 oxide by using electronic balance. Add excess copper 2 oxide in a beaker containing warm sulfuric acid and stir the mixture with glass rod to mix well. Add copper to oxide more in acid till no more copper to oxide is already mixed. It means you are using copper to oxide in excess amount. Filter the solution mixture to remove excess of copper to oxide as a residue and copper sulfate as a filtrate in the beaker. Evaporate the filtrate in a evaporating dish by heating but not till dryness. Check with gloss rod to make sure crystals are formed. Allow the crystals to cool at room temperature and dry the crystals in 3 holes of water. Hopefully you understood this paper. If you understood, then press the like button.